Now let's consider the region bounded by the graphs of these two equations. There it is. And compute the volume of the solid revolution generated by revolving that two-dimensional region about the line x equals pi. Now, in using the washer technique, the rectangle will naturally be horizontal, not vertical, like in my last example. So it is that blue rectangle that's being rotated about that vertical line at x equals pi. Yet again, there's my schematic. But clearly the thickness is a small change in the y direction, because here's a small change in y. That means my variable integration is indeed going to be y. Now, as far as the radii are concerned, since I'm going to be integrating with respect to y, I'll probably be talking about x values in terms of that variable y. So how about if I erase the name of that curve and split it up to two curves? This one is described as such. This one is described as such as well, but with a sign change. Now, the outer radius is this large x value of pi minus a small x value here. So here's my large x value. I'll subtract off my small x value in terms of y. That's the outer radius. I'll square it. I think the inner radius is this large x value minus that small x value. But that's simply going to be this large x value minus the other small x value. That inner radius is being squared. I'm looking at their differences. And of course, we will indeed integrate, as I said, with respect to the variable y. I'm sorry, I'm running out of room. I've got my dy. Certainly, oh my goodness, I forgot something. My apologies. My bounds integration. Let me give myself some more room. My bounds integration are going to be the extreme y values over that two-dimensional shaded region that's being revolved. And so the extreme y values are from clearly 1 to 3. Didn't want to forget those bounds integration.